A specific circular motion type question is using what's called a conical pendulum, like the back garden swing ball game. We take you through the brief theory behind it in one little worked example. There's a kind of diagram, mass on a string exhibiting horizontal circle. The only two forces that are in action are the weight force. Without the weight force, obviously the string wouldn't be tight, so with the weight force, the string experiences a tension. Now what you'll see with the tension, it's not in the same direction as the weight. The tension acts both horizontally and vertically. So for the next page, I've drawn the same ball again. This time we have the weight which acts vertically downwards. Adding some extra information, we have theta, the angle with which the string makes with the vertical downward direction. Like I said a minute ago, the tension acts up and along the direction of the string, but the tension has both vertical and horizontal components. So we have to work out, depending on the type of question, what these two are, but we can do it in theory. In the vertical direction, we only have the weight acts downwards, as we can see, so W equals what we're going to call TV, the vertical component of the tension. Now in the opposite direction to the weight acting upwards is TV. Now using your trig, you can see that that theta is the same as this theta. If we complete the diagram, hopefully not overcomplicating it, but TV, which acts vertically upwards, is adjacent to theta, with T being the hypotenuse, so TV will equal T, the hypotenuse, adjacent, meaning cos theta. For the horizontal component of T, which acts towards the centre horizontally, this horizontal component is the central force, which we can call FC, but using the trig and the triangle that I've tried to show is T sine theta. Now these two components will become very important when you come to solve problems. So for the next page, a little problem where I've got a mass of 0.1 kilograms on a piece of string that's exhibiting horizontal circular motion with an angle from the vertical of 30 degrees. So going to use it to work out a couple of aspects of the motion, namely the tension in the string and the linear speed of the object at this moment. So for the tension in the string, we can use the fact that W is equal to T cos theta from previously. So W is T cos theta. W is obviously mg, so that's 0.1 times 9.8 equals T cos 30. You should be able to substitute and rearrange and come up with a tension of 1.13 newtons. We can then use that to work out, like I said, another aspect of the motion, which is I'm going to do the linear speed. Now for the linear speed, we know that centripetal force is mv squared upon r. We have m, we have r, we want to know v, but we know that the centripetal force, as stated earlier, is equal to the horizontal component of the tension, which is T sine theta. Substituting the values in, 0.1 v squared over 1 equals t, and obviously sine of 30 is 0.5. Rearrange that. We've calculated t previously, substitute that in, rearrange for v, and we end up with 2.38 meters per second.